What did we know about two triangles or one triangle if it was isosceles? Isosceles. Jacob, this is a side thing. Two sides are congruent. I'm going to add to that today. All right. If the triangle is isosceles, not only are two sides congruent, we're going to add to it two angles are as well in the same triangle. My job here is to show you guys where are those congruent angles going to be, because I don't automatically want you guys to assume they're at the bottom. Jacob, how many congruent sides again? You locate those two sides. Across from them are going to be the angles that are congruent. Wherever the two congruent sides are, that's where the angles are. So if you look at my second diagram down here, I tell you AB is congruent to AC. We can all agree it's isosceles. Where are the congruent angles going to be? Across from the congruent sides. So we can say angle B congruent to angle C in this one. I got to keep stressing this, though. It's not always the bottom two. You don't have to make any extra diagrams. Just take a peek here. Everyone agree that's isosceles? Okay, where are the congruent angles now? Name them. Name the congruent angles up here. Across from Violet, the congruent side. So what two angles would be equal up here? Perfect. So is everyone all right? It's not at the bottom two. It's not always the bottom two. All right, it's whatever's across from the congruent sides. Make sense? And then we can go in reverse. What if I give you two angles are opposite? Or two angles are congruent, sorry. So B and C, given B and C are congruent. Yeah, we could say the sides opposite are equal. AB and BAC. Huge mistake that always happens, so I want you to see the mistake, so hopefully you don't do it as well. All this I just showed you only works in a single triangle. The two congruent sides, they need to be in the same triangle. The two congruent sides need to be in the same triangle, because here's what I'll get from students. Everyone see two different triangles? I'll tell you that side's congruent to that side. And then they automatically think, oh, the angles across are equal. No, they're not. Are these sides congruent in the same triangle? No, so everything I just showed you up here does not work. The two congruent sides need to be in the same triangle for me to do that. Makes sense. If they're in two different, this does not apply. Does not apply. All good. All right, I'm already tired of saying the congruent sides and the congruent angles. Can we put some darn vocabulary to these? What is the angle in between these two congruent sides up here? Name the angle we're talking about up there. What angle am I talking about in that diagram? Lucy, what angle's in between the two congruent sides? A. All right. Can we stop saying the angle in between the two congruent sides and call it by its name? Anybody know its name? Begins with a V, ends in vertex. Vertex angle. It's called the vertex angle. And yes, just like Lucy told us, that is angle A in my diagram. Angle A. Anybody know what the two congruent sides are called in an isosceles triangle?
Legs.
Yeah, legs. Legs.
Ooh.
Yep, they're called the legs. The unequal side, the outcast. Maybe some of you could relate to that one. Anybody know what that one's called? I'm not a big fan of this name, but it is what it is. Anybody know?
Base.
I don't like that name because when you think base, you automatically think what? Bottom, but no, right? That's not the case. I just showed you over here. EF would be the base. That's not on the bottom. Okay, I'm not a big fan of that. But hey, it's called the base. The unequal side, not the bottom. The unequal side is the base. And then the two equal angles. This does make sense to me, but the two equal angles, what's the side in between called?
Vertex.
Ready? Here's B and C. Those are the two congruent angles, right? What's the side in between them called? We have an actual name for it. We just wrote it down. The side in between is called the base. So these are called the base angles. I love how we just started making up vocab and we just wrote down the word base. All right, so those are all the different parts of an isosceles triangle. All right, let's go to this one right here before I start calling up people to do some work. Do you guys see an isosceles triangle in my diagram? You see an isosceles one?
Yeah.
Do you see a second one?
Yes.
Just one, or do you see a second one?
Two.
Because remember, you have to get out of this mindset starting today that isosceles equals two sides congruent. It could also be two angles congruent as well, makes a triangle isosceles. So can you see two up there?
Yeah.
Can you see three?
Yeah. Yes.
Yeah, there's three isosceles triangles there. First question, give me an angle that's equal to angle R but is not marked with an arc mark. Don't tell me S. Don't tell me angle WVS. Give me another unmarked angle up here that is congruent to angle R, because in a triangle, the congruent angles are across from the congruent sides. Okay? Give me another angle up here that should be congruent to angle R. Do we see anything up here? Where are we going with that? Kevin, see any other angle maybe?
Angle V.
Oh, my heart. There are three different options for angle V up here.
Oh, angle
Yes.
RV. Wait, angle RVU.
Thank you. I like that one much better. RVU. I want to make sure we all know, other than I just guessed because it looked like it. Kevin is using this triangle RVU, which is what type? Isosceles. What's across from the congruent sides? Congruent angles. One being R and the other one being RVU. So that's where we got it from. Ready for the Y. And this Y is going to go in your reasons column when we do isosceles triangle proofs tomorrow. And that is in a triangle. In a triangle. Congruent angles are across from, where are they located? Across from the congruent sides, or legs if you want to put legs. Well, before we move on, just to let you know a couple things. I do not care, and I will not be looking if you end up switching those two congruent sides across. It means the same thing, right? One thing is non-negotiable, though. Non-negotiable. You have to have in a triangle. Why? This fact doesn't work in a square. It doesn't work in a pentagon. It doesn't work in an octagon. It only works in a triangle that the congruent angles are across from congruent sides. All right? All right, let's go. RT. RT is congruent to, and then you know what? I'm going to actually, this is an honors level class, so not only tell me the right answer, but tell me what isosceles triangle you are using here. Okay, because I know a lot of people could just look at the diagram and probably guess correctly, but tell me what triangle is isosceles that you used. So RT is going to be congruent to, John?
TS.
TS, yep. And where's the isosceles triangle we're working with?
RTS.
The big one. Does everyone see RTS? How do we know? Because R is congruent to S. And what's across from those congruent angles? Watch, look across from them. Across. That's why RT and TS. Yep. So in a triangle, you want to start with congruent sides? Fine. Again, I don't care if you switch them around. The inner triangle needs to be there, though. And then we got one more here, WV, or VW, sorry. VW congruent to, and then let me know where the isosceles triangle was, please. VW and Kevin.
Line SW.
Line SW. Where's the isosceles triangle you're working with?
Triangle BWS.
Good job. Yep, everyone see. Why is that isosceles? Because I have two congruent angles. Across from them are your sides. Yep, perfect. And I know we wrote it twice or 3 times. It's a little overkill, but we're going to write that in our reasons column tomorrow when we start these proofs. All right, how about some algebra? I'm going to bring 4 people up again, 4 new people that did not go up for the homework. You can write with both pens. That's fine. Write with both pens and show some work and get to X and Y. So you might want to bring your calculator up with you with whoever you're working with. All right, number 1. Coming up here to work on number 1, we're going to have Sophie working with Connor. All right, Sophie and Connor on number 1. And then coming up for number 2, right next to that pair, nope, we're going to have Aditya come up with Lucia. There you go, guys. You pick 1 pen per group. And go ahead, work on both sides. You guys talk it over. Might bring a calc up. Everybody else, work in your groups. See what you got. Work in your groups. Talk to each other.
And then we have to do, so then it's 110.
Yep.
So then x is 70. Which makes that equals 70. And then, since these 2 are congruent, can do that.
You guys give Sophie, can you give the other group other pen there?
And then we have 110.
Talk it over in your group.
These have to be 110.
You should notice on Isosceles, and you can use anything you want, guys. Any geometry is fair game. I'm not necessarily saying it has to be Isosceles today, but anything's fair game.
110 divided by 2 is 50.
Oh.
So those 2
Any
are
geometry
55.
facts you have, go. Yep.
That's right, yeah. Oh, so I
So
think
110.
yeah, 180.
Just the one on the right side.
So I think
That one right there.
So those have
Let's do like a statement or anything.
No, nope. That's not a proof. Just something that's got label in your diagram is fine with me.
That's 20, right?
Yeah.
20 equals 1.
I think X is 70 because 180 minus 1. Wait, cause wait. No, cause it's like supplementary, so I think it's 180 minus 10. I think. Yeah. Alright, well.
I knew that they were
Okay, can we take a peek here? Oh, go ahead. Some of you guys aren't finished. Go ahead. Please finish 1 and 2, and then we'll talk about their work up on the board.
Trade us. She might be. I have to study. What? I'm close. I'm a few of those.
All right, let's look at these 2 here. Number 1, everyone sees an isosceles triangle on the bottom and also on top. There's 2 isosceles triangles. So let's look at the one on the bottom. Across from the sides are congruent angles where I gave you 55, so there had to have been a 55 across from the other one. Good. 180 degrees in a triangle, so we get 70 for X. Awesome job. Quick question. Why did they automatically put a 70 here now? Vertical angles. Good. Hopefully we're at that point. We see the vertical. Now we go to this isosceles triangle on top. I know there's 70 degrees already. How many degrees in every triangle? 180. So they subtracted 180 and 70 and got 110. And then they knew these 2 were equal because they're across from the congruent sides. So 70 and 55, good job. Any issues? You didn't have to get there the same way they did, but make sure we got 70 and 55. Over here, I don't think I stressed this enough. Finding unknown angles that aren't part of the answer are okay. Like, I think it's very helpful to find that one, even though I didn't ask for it. What's the relationship between the 110 I gave you and that one? Supplementary, because they're linear pairs. So that one had to have been 70 degrees. All right, that one's 70. So that meant this one had to have been 70. Why? What type of triangle is the big one? Isosceles, right? What's across from the congruent sides? Congruent angles. Right? That's that. Forget about this dashed line. The whole triangle's isosceles. So across from them are congruent angles. And then probably I think the easiest way to talk about angle Y is, again, how many degrees are in every triangle? I already knew the 90 and the 70, so the last one was pretty easy, subtracting from 180. So 20 and 70. All good? Before you go to the homework, you are going to have to factor on the last two questions. Suck it up. But reminder, you can't factor unless your equation is equal to 0. Please keep that in mind. Don't try to factor unless it's equal to 0.